Okay, students, so we're here. We're going to be practicing conditional statements, and then we're going to elaborate and create a new statement called the biconditional. Okay, so use the conditional statement. If an animal can swim, then, or if an animal is a shark, then it can swim, to identify the other forms. Then determine if the other statements are true or false. Alright, so shark is hypothesis, conclusion is swim. So let's look for, let's just dive into it. If an animal can't swim, so swim's in the front now, then it is not a shark. Shark's in the back now. Also notice how it's negated, alright? So this is a lot of work, alright? So this is actually a little review of everything. It's the converse, it's the inverse, it's the contrapositive, alright? Contrapositive. This was a lot of work. Most letters in contrapositive. Alright, and first off, we forgot to say, if an animal is a shark, then it can swim. That's true. Sharks can swim. So if an animal can't swim, then it is not a shark. So we didn't even really have to write this down. We should automatically know that it's true. Alright, a little review. Remember, contrapositive and conditional statements are logically equivalent. So that means, since I knew the conditional statement was true, I didn't even have to put it in its contrapositive form. I already knew that would be true. That's a little review from yesterday. Alright? If an animal can swim, then it is a shark. So let's analyze this one. Now, shark is in the conclusion. Swim is in the hypothesis. So we've swapped the order from the original statement, so we're always looking from the original statement down to here. So I swapped the order. So, converse. Alright? Students say they like to think swap order, shoes on wrong feet. Whatever helps you remember. Alright, so if an animal can swim, then it is a shark. That's false. Basically, any animal can swim. There's not very many animals that can't swim. What's a famous animal that can swim? Dog. I have 2 dogs that can swim. In fact, they're sitting right next to me as I make this video. They love to go swimming. So, let's look at this next one. Alright, if an animal is not a shark, so from the original, this one's in the same order, then it can't swim. But notice how it's negated. Alright? So we negated it. Inverse negate. Inverse not. Alright, so this is the inverse form. It's the same order, but not negate. Whatever you want to think about inverse, not, negate. They all sound like they start with the letter N. And this one also has to be false. Converse and inverse always have the same truth value. Alright, let me pick a different color. These are always that's a weird squiggly bracket, but these are logically equivalent as well. And if an animal is not a shark, then it can't swim. You know what another animal is? A student didn't believe me one year, but a human is an animal, and humans can swim. Woo! Alright. So, let's cruise a little bit faster through this one. Alright. If 2 angles, so we're looking at this one up here. If 2 angles add up to 180 degrees, then they are supplementary. Alright? So statement A, if two angles do not add up to 180 degrees, then they are not supplementary. So same order, just a bunch of knots. That's the inverse. It's something I forgot to do. If two angles add up to 180 degrees, then they are supplementary. That's a true statement. So we know the contrapositive is going to be true. If two angles do not add up to 180, then they are not supplementary. Inverse, that's also a true statement. If they're not adding up to 180, then they are not supplementary. Okay, now I'm going to read statement B. If two angles are not supplementary, then they do not add up to 180. So actually, let's get out the highlighter for this. I feel like you probably should have done that from the get-go. So 180, 180, supplementary, supplementary, and then we have the knots there. Okay, now in this next statement, swapping the order, but the knots remain. So this is a lot of work right here. I had to swap the order and negate. So this one will be the contrapositive. And remember, since we know the conditional is true, we don't even have to think that hard. We know this one's true. Alright? If two angles are supplementary, then they add 180 degrees. So in this case right here, from the original conditional statement, the order is swapped. Alright, there's no negation going on, just swapped the order. So it's a converse, which is true. Which is, wow, neat. We got true for all of them. Alright, so this is actually very powerful. When they're all true, we can write the mighty biconditional statement. Alright, biconditional statement's the last statement we're going to talk about. When a conditional statement and its converse are both true, thus all forms are true, you can write them as a single biconditional statement. A biconditional statement is two statements in one. It will contain the phrase if and only if. So it's kind of a dead giveaway because it's the only statement you'll see, if and only if. And you're allowed to write this too, IFF. Us math people, we hate writing. So any way we can shorten it, we will. IFF means if and only if. Alright? Or in some symbolic notations, what you're allowed to write too is P double arrow Q. Alright? That means if and only if as well, the double arrow. So, what does this mean? Write the following as a biconditional statement. So biconditional statements are very powerful. They're true in all directions. I'll elaborate on what that means in a little bit. But you eliminate the if. You write two angles add to 180 degrees if and only if they are supplementary. Kind of ran out of room there, but that says supplementary. You gotta believe me. All right, so I eliminated if. I eliminated then. So two angles add up to 180 degrees if and only if they're supplementary. That's it. That's a biconditional statement. Or, again, these are very strong sentences. They're the strongest of them all. I could write two angles are supplementary if and only if they add to 180 degrees. That's legal as well. Alright? So in biconditionals, order doesn't matter. Just eliminate the if, eliminate the then, smack dab in the middle, you have the statement if and only if. Alright? Stay tuned for more information.